Doesn't say prove. So solving question lets you work from one side to the other. Okay? And actually, before we do this solving one, I'm gonna give you some extra notes on a few other solving ones. So because solving gets a little bit tricky. So turn actually to page 600. Oh, there we go. I'm actually going to go this one first. 666, I think, is a blank page. Is that right? And we're going to look at a whole bunch of new strategies when we have to use identities in a solving question. You have already used identities in solving questions in chapter 6 even. We had it on our quiz where we had to change the co-squared in an equation to 1 minus sine squared. That's using an identity. So here are some overall strategies. And then we need to practice questions to get good at these strategies. So I'll let you write those down. These strategies include write an equation with only one trig function with only theta. Having a 2 theta and a theta in the same question is the same as having two different trig functions. A strategy we've used already was sine squared theta plus cos squared theta equals 1. Sometimes we can use double angle formulas. We're going to have to look for factoring. It's going to be a major strategy we're going to use. And sometimes we get stuck, so we just decide, just like proofs, to change things to sine theta and cos theta, eliminate fractions, and see how it goes. So here's our first question. Cotangent theta equals 2 cos theta. First of all, in this one, want to notice that it's just theta. There's no double angle identities. I also want you to notice there's nothing squared. So you can't use sine squared plus cos squared equals 1 or any of the Pythagorean identities. We just have cotangent equals 2 cos theta. Can we write this with only one trig function? Is there a way to change cotangent to just be cos? No. So we're going to have to go to our last strategy here, is change things to sine theta and cos theta and get rid of fractions and see what we have. So I change cotangent to cos theta over sine theta. Then I can multiply both sides by sine theta. To get rid of fractions. Yes. I can go back up, sorry. I got excited about, how far do you need up? Is that okay? Or even, this okay? Yeah. Anybody else need more? Okay, I'll wait till you guys catch up. This is going to happen to lots of you. This is going to happen to some of you on the take-home quiz. You're going to be tempted to divide. And it's a brilliant strategy. Do you see that if you would divide both sides by cos, they would go away? And your equation would be way easier to deal with. That is true. And you will get right answers, but you will not get all of the right answers. If you are tempted to divide, make one side equal to 0 and factor instead. Because I'm going to tell you right now, just mental math-wise, can you see that if cos theta is 0 the left side and the right side would be the same. This side would be 0, and this would be 2 times 0, and I don't even know what the other one is, I don't care. 2 times 0 times whatever is still going to be 0. 0 is an answer to this question. If you divide both sides by cos, you're dividing by 0 as a possible answer, and dividing by 0 last time I checked in math, not good. Okay? So if you're tempted to make it simpler by dividing, you might inadvertently be dividing by 0 without knowing. So instead, what we do is we move everything over and make one side equal to 0. I can move that cos theta over by subtracting, make one side equal to 0, and then you can factor, instead of dividing out by cos theta, factor out cos theta as a common factor. Now careful here, taking the cos theta out of this doesn't leave you with one cos theta. The cos theta comes out, you still have the 2, you still have the sign, but the cos theta was factored out. Minus 1. And now we're multiplying equal to 0, so we can split it here, and either this is 0, or this is 0. Both of these are on your pie plate. Cos is equal to 0 at pi over 2 and 3 pi over 2, and sine is equal to a half in quadrant 1 and quadrant 2. Reread your question, and since I wrote this one, it's nicely between 0 and 2 pi, so you don't have to change your answer. So this is an example showing you how sometimes you have to change to sine and cos, multiply to get rid of fractions, and if there's something in common and you want to get rid of it by dividing, factor instead. Okay, we are going to leave this question for tomorrow, but you can write it out in the last 3 minutes to save us some time tomorrow. And what we're going to find is that sometimes you get a double angle, like a 2x, and up till now, those have always been multi-revolution questions. But now that we've learned something new, we're going to find out other times we're going to get a 2x in a question, and it's not multi-revolution. So this slide is to help us realize, when should I see it as a multi-revolution question, and when should I see it as a double angle identity question?